Kumaravel sir, we wait for a few more minutes so that the other participants also can join.
Yes, sir. Once if you give green signal, I can share my presentation.
Yes, sir.
Okay.
Yes.
I will wait, sir. I will wait. No
Yeah.
issues.
Thank you, sir.
Okay.
Dear participants, welcome back. I hope you all enjoyed previous sessions. Now it's time to welcome our next resource person. I call upon Sri Durga, student of the Department of Central University, to give a brief intro about our next resource person for the upcoming session. Stay tuned. Thank you. Shri?
Good afternoon to all. Yes. Am I audible?
Yes, you're audible.
Okay. A very good afternoon to all. Dr. Kumaravel is an assistant professor, head of the Department of Computer Science in the School of Engineering and Technology, Pondicherry University, Karaikal. He is specialized in human-computer interaction, machine diagrams, and theory of computation. He has received a Best Teacher Award by Pondicherry University based on students' evaluation continuously for past 6 years from 2013 to 2018. He has received Young Faculty Award for the year 2015 from the Venus International Foundation. Okay. And he also received 2 Best Paper Awards in the international conferences organized by IITs. Mute your mic. Thank you so much for your presence. Now we call upon Dr. Kumar to continue the session. Over to you, sir.
Thank you, madam. Whether my voice is audible?
Yes, sir, you're audible, sir.
Yes. Thank you. Thank you. Dear participant, I request you to mute your mic and turn off your camera so that it is easy for me to continue my presentation. It is my humble request. Now I am going to share my screen. Hello? Is it audible? Okay, sir. Visible. Thank you. Thank you, dear participant. Yes. I think of this MPP and the title that I am going to discuss with you is using R. So in this particular session, I am not going to educate you any rocket science like this. I am going to explain you or discuss or interact one type of an application with respect to the domain of data science, that is text analytics. I don't know how many of you are well versed with this particular area, text analytics. But if you are new to this field, I am going to discuss with some running examples so that you can easily understand what are all the various nuts and bolts behind text analytics, both theory, and at the same time I try to give a practical demo how to perform text analytics using our programming language. So right now, for data science, most of the people are saying that Python, but according to me, I will go with R. If you ask which one you have to use, again, it's your own cup of tea. Which one you like, you use it according to your interest. That is the thing I want to say right now. Are you able to see my second slide? Then thereafter I will never ask you, right? Just a form of interaction. Yes, sir. Thank you, Kavita. Yes, thank you. So this slide will capture what are the things I am going to discuss right now. Again, I already said that I'm not going to in-depth analysis of text analytics. It's more or less an overview about text analytics and some research purpose. That is the thing I'm going to do right now. And for another, say for example, roughly 90 minutes, I'm going to discuss this kind of things. What are the things? Number one, how to find document similarity. That is a first part, I can say like that. So by using some algebraic operation, especially linear algebraic operations, how I am going to use in text analytics. That is the thing I am going to discuss in part one. That is for another 30 to 40 minutes. And next, most one of the core area of text analytics that I'm going to is document classification, because nowadays in data science, a very, very, very important problem, right? Domain, you can focus your research. So here, I'm going to touch upon ML and DL perspectives, but it is not easy for me to cover all ML algorithms and DL algorithms that can be used for text analytics. But surely, I will give an in-depth, I will experiment with one algorithm with respect to how text analytics can be done by using that particular ML algorithm. But I am not going to cover. So make the PPT full. Just you pin my so that it will be easy for you, because for interaction purpose, I am having this kind of an arrangement, because I want to see how many of you are chatting, because most of my session will be in interaction format only, so that I will see your query and I will answer. Otherwise, I can postpone all my queries. You can ask questions at last. I will answer all your queries. Can I go with like that? Or you want interaction session? Dear participants, anyone? Say yes or
sessions. We won't have interactive sessions.
Super. I think, okay, fine. So hereafter, whatever may be the doubts you are having, you can stop my lecture and I will clarify your doubts, and then we can proceed. Okay, fine. Still, I have not gone into my business. I am just giving an intro about text analytics. What I am going to discuss for another 90 minutes. Yes. Again, I'm saying I'm going to do only two analytics. I'm on a text, that is similarity analysis and classification. So classification, I'm going to deal with some machine learning. Okay, fine. But here I'm not touching upon the perspectives of DL, because it will take too much of time. So if another session is there, related to DL perspectives. Whether it is a similarity analysis or classification, I have to represent document text. Participants, you can think of text and document both are same. So going to do some analytics, you have to represent the text. The fundamental thing, document representation. So there are several document representation techniques are available in research, right? And to choose a well-known model for document representation, that is vector space model. And if someone has already worked in text analytics, I think you come across with vector space model. Now, after 30 minutes, I think if you are alive during my lecture, surely everyone will understand how how a given document or text can be represented using vector space model. So after a text is represented using this vector space model, then only I am going to do some analytics. Right. I already told that I am going to do some two primary analytics. One is similarity, another one is classification. Here I am going to discuss about some cosine similarity, which is well accepted in research community. And next, I am going to give a live demo on how to perform classification using the machine learning algorithm, a well-known machine learning algorithm, Navy Bayes algorithm. I think everyone knows Navy Bayes algorithm. Audio not clear. Why? It's okay. Now it is okay. Thank you. Thank you. Thank you, dear. So I think most of you know Navy Bayes algorithm. If you're having any doubt, I can also explain the nuts and bolts of Navy Bayes algorithm. Okay, fine. So that is the thing all about I'm going to cover. So after explaining theory, after explaining all these concepts with an example, I will give a demo in R. I think in R Studio, right? So I think if you are not familiar with R, no problem. I will explain the syntax now and then, and I will explain everything. So that is my agenda. In this way, I am going to focus my talk for another, say for example, roughly 80 minutes. Is it okay? Can I participate anyone?
Yes, yes, sir.
Thank you. Thank you. Thank you. Yes. A small introduction, introduction about text and its analytics process. So what is first of all a text in data science, where I can take? So for that, data is a very important thing. So if I'm asked what is data, right, to a mathematician, so surely he will give an answer discrete or continuous. In this way, he or she will say. If I am going to ask this question to a physicist, he will say digital and analog. But being a computer science professional, if you are going to ask this question to me, I can say like this. A data, it may be structured, unstructured, or semi-structured. And if you ask the same question to a social scientist, social science, he will give the answer primary data, secondary data. He is having its own meaning. Coming to the computing point of view, right? Structured, unstructured, and semi-structured. I will go with that. So any data that is organized in terms of rows and columns, I can say that is a structured data. But today we are going to discuss about unstructured data. Then what is unstructured? So text is called what? Unstructured. See, if you see any document or text, it is like a free flow of words, right? Sentences, paragraph, right? And lengthy pages. So that is a thing I will say it is a unstructured data. So our free text is our unstructured data. Apart from structured and unstructured, there is a one form of data is there that is called semi-structured. I can give an example as XML, right? So some part of a data is structured and some part is not structured. Why I am saying structured? With the help of tags, So I am saying that type of data is semi-structured. But today my lecture is going to focus, my talk is going to focus only on text, that is unstructured data. So now I have given some input related to data, that is structured, unstructured, and semi-structured. And I am going to deal with this unstructured data. That yes, why I have to look into this unstructured data? Because of the rapid growth of text. So if you open www, so everything mostly it's text. In your desktop, text. Your email, text. Internet, blog, literature, newspaper. So wherever if you see these pages, compared to structured data, you will find only unstructured data. That's why my focus is toward text. And at the same time, really, if you want to do some research, yes, text is a very nice data in which you can work. Oh, you can also work on some other data like image, video, right? Structured data set. But according to me, I will say there is a lot of scope with respect to the concept of text. Finally, I will give some research perspective also. Yes. At the same time, I want to say the reason for going for text analytics, because compared to structured data, right, 90% of data are only in the form of unstructured manner. So since there is a huge amount of information, text data is there. So why can't we focus our research towards that area? That's why. Yes. So yes, I told that there is a vast amount of unstructured data that is text. What we can do on that particular data, right? So what next? So yes, now it is a time to necessary to automatically, that is a, please underline the word automatically, without any human interaction. I have to analyze the documents properly and I have to organize it, right? And most importantly, if there is a need, I have to summarize it. It's not necessary to do all these things. Depending upon your application, depending upon your need, you can choose any one particular task. So this is not a new terminology, text analytics. It's already existing one is their text mining. Nowadays, everyone calling it as an analytics, but it's also an equivalent field like text mining. Okay. So before going to discuss anything, you have to know what is input and what is an output of a particular concept. So I already told that text mining, text analytics both are same. Yes. So what is an input to any text mining algorithm or text mining engine or text mining model, right? So input is a document text. That's all. Say for example, if I'm going to take some 1 lakh tweets message, yes, each tweet message is my document. Yes, if I'm going to take WhatsApp messages, again, it's a document. If I'm going to take an articles, right, which is published in in any reputed journals, yes, it becomes a document. That is simple. Any document, any SRS, software requirement specification of a project, yes, it's also a document. So this is an algorithm model is a text documents. So what I am going to do? Yes, I can find is there is any pattern exist among the documents. Is there is any connection? What is a profile? What is a trend? So these are all the things I can look into that particular documents. That should be non-trivial. That should be hidden. All these kind of features should be there in these documents. So all about text mining is as for the trees, I can say like that. Yes. So I will go with a small definition, then I will go to the actual similarity analysis here. Yes. So I inherited this particular definition from data mining only. So in text analytics also, you are going to find something that should be interesting. And at the same time, I told that it should be non-trivial, hidden, previously unknown, and potentially useful. That is very, very important. If it is not useful, then what is the necessity of doing any kind of an analytics, right? Okay, I can go with this definition. Yes. And I want to add something. Why dealing with the text is tough? Yes, because there are countless of words are there. And there are different ways in which I can represent one particular concept in with an abstract with a lot of abstraction. And at the same time, it's very difficult to visualize the words, and leads to high dimensionality, number of words, number of features I can say. Okay, fine. But why it is very easy? Because most of them are redundant data. That is a very, very important thing. It's not necessary to take all the words into consideration. Okay, so that's why there will be a lot of redundant information will be there. So I am saying doing some text analytics is the easiest job. And there are some simple algorithms, some good algorithms are there, important phrases and meaningfully related words. So I am saying text analytics is a easiest thing. Yes. So before going to touch upon this particular field, is there is any necessity for me to have the knowledge about some other field of science? Yes. Natural language processing is a very nice domain. It's a subject you have to know, dear, if you really want to focus your research towards text analytics. And at the same time, machine learning. I'm going to explain all these analytics by using machine learning algorithms. Old subfield in A, that is information retrieval. So these are all the various concepts Sorry, not concepts, subjects you have to know if you want to master in the field of text analytics. Yes, I am coming to the process. Now I am coming to my business. My business is text analytics using R. Okay, fine. So now I'm going to explain you in another 5 minutes of time what are all the processes are there in text analytics. Whether dear participant, are you able to follow the lecture?
Yes, sir. Yes, sir. We are following, sir.
Thank you, thank you, thank you, thank you, thank you. Yes. Again, I'm inheriting the same diagram. That is a well-known diagram in data mining for explaining the concept of text analytics. See here, the what is the raw input that I consider? I'm going to take only text. Otherwise, I can call it as a document. Fine. So what the first activity I have to do? The first activity I have to do is text pre-processing. I already told that, because a lot of redundant data will be there in the text. I have to remove all this redundant information. So that kind of activity, text pre-processing, it has its own research avenue. The text pre-processing has its own research avenue. After pre-processing the text, you have to transform the text. Why I have to transform? For uniformity, for providing some structure, for normalizing. For that only I have to go for transformations. Again, text transformation has its own research avenue. And next is feature selection, because all features are not important, right? That concept is called feature engineering. They will say some please pre-processing should remove unwanted things. Processing. I will explain you here all those steps involved in processing within just 10 minutes or 15 minutes time. Don't worry. Just explain you what is information, feature selection, everything.
Sir, voice is breaking, sir.
Now is it okay? Now is it okay? Now is it
Also breaking, sir.
still breaking? Because
Yes, sir.
everything is right in my side. Okay. No, sir, breaking. You can text in the chat box. Not clear. Not clear. Still breaking. Okay, I'm not speaking anything here. Now I'm going to start speaking. So if you are having any problem, you can say. So in this architecture diagram, you will see text pre-processing, text transformation, feature selection, everything. I think is it okay? Now the voice.
Yes, sir.
I think
Yes, sir. Yes.
I think go ahead. I think someone giving a very good feedback regarding voice is okay. So that I'm going with I'm proceeding here. Okay, thank you. Yes. Now I am going to adapt an information retrieval style for text analytics. I said that there are different mechanisms in which you can attack. So I am going to explain an information retrieval style. Yes. So someone asked the question, what are all the things you are going to do in text pre-processing? Yes. In text analytics, these are all the normal things you will do. Skimming, stopword removals, weighting of terms, and how to represent model, I told that. So vector space model is a very, very important model for representing the text, and finally some algorithms. So these are all going to discuss right now in detail. Yes. So this is the overall architecture you are seeing in this slide. So the input is my raw text. I'm going to perform stemming. Stemming means finding the root. I will explain you here with an example. Don't worry. Next is stopword removal. Stopwords means there are certain words which doesn't have any kind of meaning. Say for example, some is, was, like that. So so there are certain words. Apart from verb, right? There are some words which doesn't plays a vital role. So that word stopwords. With respect to one particular language, Tamil has its own stopwords, Malayalam has its own stopwords, English has its own stopwords. Any language in the world has its own stopwords and its own algorithm for stemming everything, right? So, perform stemming and stopword removals only. So, after performing stemming and stopword, the text will be broken into tokens, words. And then I'm going to assign some words because having this unstructured information, you can't do anything. So you have to provide structure to this unstructured data, right? How? Yes, that is possible through by means of weighting mechanism. The weighting mechanism that I'm going to educate you right now is document frequency, term frequency, and inverse document frequency. This is all mathematics. Again, I'm saying here, if you want for research in the field of data science, you have to be very strong in mathematics. What mathematics? It's not rocket science mathematics, linear algebra, statistics. So these two things, I think it's okay. You can do some wonders in the field of data science, right? So here I am going to explain you a linear algebra operation that is matrix, right? Matrix operation only I am going to deal with, right? So after representing this unstructured data in form of a structure, means of vectors, right? You can do any kind of explain you the concept of how to perform similarity analysis and how to perform classification. So now to explain each component in this diagram with an example here. Yes. Now I am going to focus on vector space model. So give me 1 minute of time. I will switch off my fans. That's also creates some kind of disturbance. Give me some 20 seconds. Yes, I switched off my fans. Okay, nice. So now, dear, so the first part is not over. 75% of part 1 is finished. Just I have give an introduction about text analytics. I said that document representation is very, very important concept in text analytics. Now I am going to the vector-based model. That is the model that I am going to adapt for document representation. Yes. So I already told that I'm going to do some kind of a linear algebraic operation over here. See, some sentence wise, I have ordered my presentation. I will provide all PPTs and R files to you. So it's not for me, it's for you only. I will give it to you. So I'm not going to explain word by word, right? So I'm directly going to the model, right here. So in vector space model, so each document is considered as a point, a vector. That's all, simple. And each document has collection of words, and each word I am going to call it as a dimension. So in a vector, see you are see D, a point in a vector, which having W1, W2, etc., Wm. Here W1, W2, etc. words that constitutes in the document D. Similarly, if I am going to have 10 documents, so how many rows of information I will have? 10 rows of information. Say for example, if I am going to have M words, then number of columns here I am going to have is WM columns. That's all. Now everything, this unstructured information is converted into a matrix, a n by m matrix. N rows constitute the documents and m row columns constitutes the number of words. Otherwise, they will call it as terms or feature. That's all simple. Again, some problem is there with respect to text. Why? There are so many English words are there. Yes. How to determine the importance of the words? Right? It is very, very easy to tackle these two problems. Say for preprocessing. So by using preprocessing, I can easily handle this problem number 1. Right? Because I'm going to eliminate useless words in one particular language. If it is an English, which has its own some list of words which can be called as stop words that I can remove it automatically after performing that particular algorithm. At the same time, by performing stemming, that is finding the root words. I will explain you with an example. You wait for another just 5 minutes of time. Right. Okay, fine. And I said that which word is something more important in a document. That can be determined through some weighting schemas. For that, I am going to use the term frequency and inverse document frequency schema. It's a simple mathematics. It's not a rocket science. How to find the weight of a word? See, this is a simple mathematics. A term frequency of a word. Term frequency means number of times a word. That is called idea of a word, inverse document frequency. So by multiplying these two factors, you will find the weight of a word. Then what is idea of? That is a mathematical formula. Total documents divided by document frequency. Then what is document frequency? Number of times a word occurs in a set of documents. That is called document. By taking this fraction, you can easily find out idea, right? So the most important thing to know here is, if you want to find an importance of a word by using the terminology of term frequency and inverse document frequency, right, you can easily the answer to the second problem, how to determine the importance of the word. Yes, that's all. I think this simple mathematics is enough to do some kind of document representation. Yes, straight away I'm moving. I'm not going to explain in theory, okay, because I have to give a demo also. See here, you are seeing one slide, right? So this is the input, and that is an output that I'm going to generate. So the input is my original text, okay. I have taken from one magazine, and finally what I am going to do, after doing all pre-processing, transformation, feature engineering, right, I am converting this particular text and I am going to represent by means of numbers. That's all. How that is the thing I am going to explain right now. See here, you are seeing a lot of words are there. See, that is a word, resort. See here, by doing some process, I am going to assign a number, a numeric value, right? That is a one dimension value. That is, I am going to give it as 0.624. How I am going to assign the value is 0.624 for result. That is the thing I am going to explain you with a running example here. Yes. Is it clear so far? Now I am going with a running example generating the same example. So see here I am taking three documents. You are seeing the documents in yellow color, right? So the first step in text analytics is you have to extract the text. Extracting the text means you have to remove the prepositions. Prepositions means full stop, comma, apostrophe, like that. So these characters are called prepositions. You have to remove it first. This is called text pre-processing here. One participant asked what are all things text pre-processing. The step one is text pre-processing, right? That is extracting the text. See here in the first document, there is a sentence. For simplicity purpose only, I have taken a small sentences, right? So this is a data mining course. Here there is a full stop, I removed it, right? You are seeing the output in the right hand side. So input is my document. Three documents I have. So I am performing extraction of text. I am removing full stop. Yes, here two full stops are removed. Yes, in second document. Here a comma and full stop is. That is, you are seeing the output in the right hand side. That's all about the step one activity in text analytics with respect to extraction of text. Next, I am going to explain you how to remove stopword removal. Yes, a well-known benchmark algorithm is there for stopword removal. That is, we are using Stanford University algorithm for removing the stopwords. I think around 48 words are there in English is considered to be right. It's a question mark. How many words to be there for each language? Tamil has its own stopwords. Malayalam, Telugu. Now we are working in Odisha language, right? Each has its own stopword list. Similarly, here you are seeing in the right hand side the word this is, yeah. So these are all the standard words which is considered as stopword by Stanford University stopword algorithm. So I am removing that words from the documents. This is my second step. Slowly, just to see what I am doing in document 2. We, are, is, yeah, of. So these are all the words in second document. I am removing it. I have differentiated by using some gray color. I think you are able to visualize everything. Similarly, I am doing it for the third document. So that's all about stopword. Stopword removal means removing the unwanted words. I can say like that. I never say it's an unwanted words, and yes, I can go with it. Okay, not necessary. That words never gives any kind of meaning to my document like that. Okay, fine. So the step 3 is a very simple step. It's not going to add any weightage because here in text analytics, no letter can be considered as a uppercase or lowercase. All things should be in equally you have to treat. That's why the third step is converting all the uppercases to lowercases. Okay, here text in second document you are saying, text is a word, it starts with capital letter. So now what we are going to do, we are going to convert into small letter. That is a simple step. I think similarly, I think you will also look for document 3, the mining, the word mining, right? So the first letter is initialized, converted into lowercase. Okay, fine. So the fourth important step is stemming. Stemming means finding the root word of a word. That is called stemming. Say for example, running is a word is there. What is the root word? Run. Again, applied Stanford University stemmer, right? Because the research is saturated in stemming, right? And stopword removal also, right? Okay, fine. So, say for example, there is a word here, mining, So after performing stemming, I am able to find the root word mine. Similarly, studying, study, right? Interesting, interest, interested, interest. So this is the way in which I can find the root word of a given word. So that is these are all the activities which is we are preprocessing. So that's all about me. Next, a very, very important thing is now we are going to pre-take two words. Right. So for that you have to do some kind of analysis that is called finding word frequency. Word frequency means counting the number of times the word occurs in a given document. Say for example, sometime I put it in green color and I have ordered in chronologically, right? See, there are 3 words are there in this document: data, mind, course. So all are identifier. That's why I have given X like that. So on chronologically, if I want to order, the word course comes first, data comes next, and mind comes next. Okay, in this way. How many times course is there? Only one time. So X1. How many times data? One time. So I put X1. And how many times? One time. Similarly, in second document, if you see, the word mind occurs thrice. So I have put X3. Just for differentiation purpose, I have put like that for better understanding also. Similarly, data time, mind thrice, study one, subfill one, text twice. I think it's very clear for everyone, right? Similarly, if you see the third document, you are seeing interest is the word occurs twice. So I have put X2. Similarly, mind occurs only once, one. Yes, that's all. I think now you understand step 5. Step 5 is just counting the word frequency. The number of word occur in a given document. That is it. So that's all about word frequency. Next, I am going to create some index file. Yes, here I am going to find the document frequency means, see, a word, how many times that is document frequency.
Hello, sir. Kumaravel, sir. Sir, your voice is not audible.
Sir, now it is audible or not, sir?
Yeah, now it's okay.
Okay, sir. Can I proceed, sir?
Yeah, last 2 minutes there was no voice.
Okay, okay. I will start.
Yeah.
I have stopped here. I think step 4, stemming. Right. Stemming means finding the root word of the given word. Stemming. So the step 5 is counting the word frequency. Say for example, in this document, I am having 3 words: data, mine, pose. How many times words occurs in this document? That's all about this counting the word frequency. So for example, the word pose, right, occurs only one time. So I have put x1. Similarly, data one time. Mine occurs one time. Similarly, in this particular document, second document, the word mine occurs thrice. Study occurs once. Text occurs twice. See here, text one, text two. Text occurs twice. Like this, I have to find out the word frequency of all this document. That is all about step 5. And next is creating the index file. We are 80% covered how to represent the document in vector space. Fine. So here I am going to concentrate on finding the document frequency. So here in these 3 documents, in a simple document, number of words should be in thousands only, right? Okay, fine. So here, let us see how to find the document frequency. See here, the word course occurs only once. That is, it occurs only in document 1. So data. So it occurs in document 1. It occurs in document 2. So similarly, the word interest occurs only in one document, that is in document 2. So that I have put 1. Even though its term frequency is 2, I have represented the document frequency as 1. Similarly, the word mine occurs in all these 3 documents. So it is document frequency is 3. Similarly, in the steps 6, I am creating the document frequency. Now it's a time to create the vector. It's a dimensional array. I told that in these 3 documents, after performing 6 steps, I am able to know that there are 7 words. So my length of the vector is 7. Yes. So see here. So in document 1, I am having 3 words: post, data, mine. Okay. So let us see here. According to alphabetic order, post occurs. Whether the word post is there in document 1? Yes. So that I have put 1. Similarly, the word data is there in document 1? Yes, it is there. So I have put 1. Whether the word interest is there in document 1? No, it's not there. So I put 0. Similarly, I created a vector for each document. That's all. It's very simple. Right? So it's a very, very simple thing. Right? So after calculating the term frequency, after calculating the document frequency, I'm writing this thing. See here, I'm just writing the document frequency in only in the vector, not term frequency. That is an important thing you have to note. See, let us consider for 3. What if duplicate? Remove it, sir. Duplicate, you remove it. No need to have any kind of duplication. You can remove it, right? You have to get only the unique words. A very nice question. Uh, very good. So, but frequency, sir, remove it. You have to take it only once in frequency. Say, for example, here, let us consider mine. Let us consider the word mine. It is occurs thrice, right? Document 1, document 2, document 3. Okay. Okay. So document frequency is 3. But here you are not representing in the document 2 itself, it's occurred thrice. You are not writing that one. Okay. Fine. 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 Yes. Now this is the most important thing. Sir, in different centers of say, Okay, I will come up with this thing after finishing this exercise. I'll come up with it in answering your queries here. Right. So the most important thing is finding the inverse document frequency, because this inverse document frequency only gives the importance of the word. Right. Okay. The formula is very simple. That is, I already told it, the logarithm of total documents divided by document frequency. Let us see here. These are all the vector we have created. How I am calculating the IDF of the course? So here seeing there are 3 documents are there. So if I want to find the inverse document frequency of the word course, what I have to do? It's a logarithm of, this is a simple logarithm of total documents, that is 3 divided by document frequency. What is the document frequency of the word course? It is 1. So it is log 3 by 1. So log 3 by 1, log 3. So log 3 value is 0.477. That's all. So in this way, you have to calculate the IDF, inverse document frequency. Similarly here, data, that is IDF of the word data, which is equal to logarithm of total documents 3 divided by document frequency. Document frequency is 2. 3 divided by 2, that fractional value, right, logarithmic, we will get 0.76. Like that, we will calculate the IDF of each word. After calculating the IDF of each word, just multiplying the IDF with the corresponding vector values, you will find the weight of the words. That's all. So the weight of the words equal to term frequency into IDF. So I already in the vector, so IDF calculation is to be done by all these things. Purpose for in-depth understanding only, I am educating all these things by using R and Python. Standard packages are there. By writing a simple function, compute everything. No need to compute all these things. Writing a simple line to do it. So I think time is very less for me. Right, I will go very fast so that I will give a demo on R so that you will get some better understanding. Okay, fine. Okay, I'm going right. Just I'm calculating the weights. Just multiplying the term frequency into the IDF of the word will give the weight of the word. See here. That is 1 into 0.47. I'm getting the value. Corresponding 0 value into something, it will give 0 only. So in this way, I can easily construct a vector. Now, I have given some weights to the words. Previously, the words, now it is numbers, some numbers, but all the numbers are not uniform. I said that, transformation, something more important. So for I'm going to do I'm going to normalize all the documents to unit length. So the standard formula, everyone knows how to normalize to unit length, right? So this is a simple, that is, I know the weight of the word, I know weight of each word. So the formula is the weight of the word of a single word is determined by weight of word divided by square root of weight square of word 1 plus weight square of word 2 plus etc. How many words are there in the documents? All the words you have to consider in the numerator by taking square root. So if you are going to do that, I can find the unit length of the entire document. So that's all. Now the entire text input is converted into numerics in terms of matrix. So here I am having 3 by 7 matrix. You are seeing after converting all these vector into unit length, I am getting this value. That is 0.938, 0.346, for document 1. Similarly, for document 2, I am having certain values. For document 3, I am having certain values. How I am going to calculate all these things? By using some programming languages, especially Python or R, you can do it very simply. I will explain you everything, don't worry. Right. So that's all. Now I represented the document through vector. So that's all finished. My job is over. Now, whatever may be the activities you are going to perform in text analytics, you are going to carry it out all these steps, right? First task is you have to represent the text. You have to represent the documents, either by using a vector space model or still some advanced models are there, right? IDF, TDF is there. Frequency, document frequency is there are several methods, right? Okay, backward model is there, right? So that is the thing. Now you can apply algorithms, right? So the first thing I'm going to several methods are there. So the similarity analysis I already told it. Classification you can do, clustering you can do, information extraction you can do, Name entity extraction is there in text analytics, and text summarization is there. Still, there are a lot of application areas that are there. I'm going to focus on similarity analysis and classification. Just right?
Sir, voice is breaking. Voice is not coming.
Check the audio. No voice, nothing.
Hello, sir. Do you hear me, sir?
Is it okay? Is it okay right now? Hello?
Ah, yes, sir. Yes,
Hello?
sir. Voice is okay. Now it is okay. Voice is okay.
Okay. Okay, thank you, sir. Thank you. Okay, sir. Is it?
Ah,
Can I
yes, sir.
proceed? Can I
Yeah,
proceed?
please proceed, sir. Please proceed,
Thank
sir.
you. Thank you. See, dear students, so far, sorry participants, sorry for the disturbance, right, that I caused. Okay. So I'm saying that by taking cosine similarities among the documents, right, you can find how one document is similar to other document. For that, what you have to do, you have to take two documents and you have to perform two tasks. You have to do some dot product multiplication, right? So if it is parallel, right? Because I said that it is not it's an angle theta, right? If it is parallel to each other, then you can say the documents are very similar in nature. And if it is the angle is something more, if it is ortho, conclusion you can receive is the documents are not similar. So that's the thing you can get it there, right? By doing the cosine similarity analysis. In Python, that can be done by using by calling a simple library function. You can perform all these things. But in R, that function is not available, right? For that, I have written my own package. I will explain you all these things with an R code. Yes. See here. So I'm going to capture everything right in this particular slide. I have taken three documents. Here I have not performed IDF, inverse document frequency. I have performed only term document frequency for simplicity. See here, how many documents are there? Documents? Document 1, document 2, document 3. How many terms are there? How many features are there? 7 features are there. That is course, data, interest, mind, study, subfield, and text. Right. So just I have put term frequency. Right. See here, in document 1, yes, course is there. Data is there. Interest is not there. Like this, I have formed a matrix, 3 by 7 matrix. Okay, fine. And this is my standard formula for similarity analysis. And I have calculated, right, the similarity. That document 1 to document, obviously these two both are same, so I will get the similarity of 1. Similarly, document 1 with document 2, I am getting the similarity value of 0.989. So mostly it is nearer to 1. So if it is having less than 0.5, automatically you can come to a conclusion that these two documents are not similar in nature. Like that, you can do some kind of analysis. You can for what is the real time, I can say you some 100 tweets, right? And you do some similarity analysis, and you can Please repeat cosine similarity. Okay, I will explain, sir. Okay, so you take some 100 ticks and you can see how the persons are likely or tuned with their mindset, right? Okay, like this you can determine, right? See, for example, here what we are going to do, how one article is relevant to other article, we are doing like that. Similarly, nowadays a lot of articles are coming related to 19, so we are doing some kind of analytics, right? And at the same time, lot of cases are reporting, so we are doing some analytics and we are seeing how many similar cases are happening in different parts of the world. So you can think any kind of an application with respect to similarity, right? And you can come up with some kind of an application, right? Really, it would be helpful for the society too, right? Someone asked cosine similarity. Cosine similarity means after converting the document and after representing the document into vector space model, what I am going to do is, yes, what? Someone asked this something. Yes, audible, sir. Okay, okay, fine. And now I am going to, you have received one message. Okay, fine. See, and now I am going to explain what is cosine similarity, because someone asked. Cosine similarity means taking two vectors and I am going to do dot product multiplications. That is A dot B divided by modulus of A B, right? So the in-depth values are sigma I equal to 1 to n number of words in document A and number of words in document B divided by square root of sigma I equal to 1 to 1 A I square, right? With respect to document A. Similarly, sigma square root of sigma I equal to 1 to n B I square, all the words in document 2. So this is a simple multiplication here, right? So that is cosine similarity. Okay, fine. Yes. See, say for example, I said that in how I can visually represent these similarity values. I already told that through by means of an angles. See here you are seeing, I given some visualized manner of cosine similarity. See here you are seeing document 1, document 2, document 6, document 5, 3 and 4. See, now you have to compare the angles between the document 1 and document 2. See, the angle is very less compared to document 2 and document 5. It's having more angle. So you can say that these two documents are different documents. The document 1 and 2 having lesser angle, right? So that you can say, yes, these documents are similar in nature like that. Okay. So that's all about document similarity. Now I am going to explain whatever concept we have learned. I am going to run it through our software, right? Okay. Wait a minute. I am going to start my R Studio. Are you able to see my screen? Are you able to see my screen?
Yeah, yes, sir. Yes, sir. Yes, sir.
Right. I think how many of you are well versed in R? I don't know. So this is an interface. Here, anyone knows R? Participant? Unmute your mic and you can say something, so that it's very easy for me. Nobody responding? That is, I am audible. I received some message. Yes, sir. Okay, fine. Audible. Okay, fine. Okay, I'm directly running my R4DL. Yes. See, I said that everything is easily done through by means of R program. Yes, it is possible. Yes, I think most of you know the Python programming. Personally, I will compare Python programming R and I will explain the code, everything for you. Yes. So the first line of code, what you are seeing? Anyone? First line of this code. Anyone? Participant?
Yes, sir. Yes, sir. It's visible, sir.
Okay, fine. You are seeing the first line of code is library of TM.
Ah,
So
yes, sir.
library, yes. So TM is my package. Then import, you can use the function library, right? Here the package name is TM. TM is text mining. Okay, you have to import that library. Yes, I'm importing it. Here in Studio, you are seeing some 4 windows. This is window number 1, window number 2, window number 3 and 4. See, this is the where I can write my R script, and console where I can see my output, and in the top seeing my environment where you can see all my variables, data set, everything. And bottom right, you are seeing a window where I can find out if it is going to be visualized in terms of graphs. And if I want to install packages, because in R I have to install packages in online, so I have to install packages from here. And at the same time, I can get help like this. Okay, so there are 4 windows are there in RStudio. It is an interface for writing, for executing the R script effectively. Okay, now I am coming to the coding part. Right, the first line of the code is library. I am importing some library TM and Snowball C, which is necessary for me to perform similarity analysis. Okay, fine. Now I have to get the data. Data is something more important. My fine. I can store my data either in CSV format, JSON format, whatever may be the format. That is a advantage of similar to Python. I think there is a possibility for me to open. Right. So here I am using it by using the function called read CSV. Right. The same example what I have discussed. I'm going to run it here. Yes. Line by line. Yes, I'm running my first line. Yes, the necessary packages are loaded. You are seeing it in console. TM was built under our version. Right? I'm installing Snowball C. Yes, it is installed. Now I'm taking my data preparation. I'm opening my data set. Yes, it is asking the data set. Yes, I'm opening it. See, I'm having it here. Sample data set. I will show you what is there in this data set to you. Yes, I will running it. You are seeing here. Now you observation one table. Just see. So see, there are 3 documents on there. This is a data mining course. Whatever may be the example that you have seen, for that only I do similarity analysis. Now I'm going to prepare, right? In text analytics, I have to pull down all my documents. So that is done by using the function called the corpus, right? See here, I'm running the corpus. Yes, if you print the meta description only. See here, there are 3 documents are there. Okay, like I want to inspect what actually is there in the corpus. For that, there is a function called inspect. I'm going to inspect the first to second document. Let us see here. Yes, again, it's giving the meta document description of document 2. So if you want to see what is actually there in that document, for that I'm using the function called as.character, right? Yes, I'm running it. Now you are seeing the content in that particular file is, this is a data mining course. Similarly, I'm going to find out the same manner by using the function called lapply, right? It's a very, very important function in R that can appear, you can put it in the corpus and you can see the text content, right? I'm running it. It's very simple. See, these are all the 3 documents. Yes, super, finished. So now I'm going to perform all these 10 steps, right? Because I have to represent the document using vector space model, right? First, I'm going to do some cleaning, right? That is, I'm going to convert into all the uppercase to lowercase by using the function called TM. TM map is a function that I'm going to call. It's not necessary to do any simple calling the function that will do the job. Yes, I have removed all the upper cases to lower cases. Again, I'm going to apply it to, you are seeing, yes, you are seeing the output here, right? This is a capital word, it starts, now it is converted into small letter. Similarly, this mine is converted into small letter. Super, fine. Next, I'm going to perform removing numbers. Say for example, numbers never gives any kind of an information in text analytics, right? So I am going to remove the numbers which is there in the document. Yes, I remove the numbers. Again, I apply function. You are seeing the same output because there is no numbers in this document. Next is stopword removal. I said that you can easily remove the unnecessary words by using the TM map function by providing the appropriate arguments, stopwords. Right. I'm running it. Yes. Now the corpus is all the stopwords are removed. Next, I'm removing punctuations. Yes. I removed all punctuations. Next, I'm performing stemming. I already told that stemming means finding the root word of the document. That is the thing I'm going to find out. See here, you are seeing mining. Now, after performing this function, this mining is going to be converted into mine like that. It's going to be converted. Let us see. I'm running. Yes. You are seeing the output. Yes. See here, the mining is converted into mine. Yes, I found the root word. And next, there are a lot of white spaces will be there, tab spaces like that. I have to remove it. It's text preprocessing. Right. I'm removing all the white spaces. Yes, I have finished. That's all. Mostly all the text pre-processing activity I have performed. Now I have to go for document representation. Right here, I am going to use the function called term document matrix. It is a simple function which is available in our programming, which converts the corpus into a structured form. Right, that is the thing I am going to perform right now. Yes, I created corpus underscore TDM. See here in the top right corner, you are getting all the variables, right, which is in the memory. Right. Now I am inspecting the particular term document matrix. See here, whatever may be the index file we have created in theory, theory part, the same thing is created right now. So number of terms and here number of documents. Now I am converting that particular structure into data frames for my computation purpose. Yes. Now I have written my own, right, for cosine similarity, that is A dot B divided by modulus of AB. For that I have written my own, right? I am running the function cosine. Yes, I run. Okay. Now I am going to apply it to, sorry. Now I am going to apply it to the data frame, my corpus TDM data frame, right? So now you can see the answer. Similarity, cosine similarity is my user defined function, right? The formula for cosine similarity, for which I have running two loops because I have to take rows and columns. For that only I have running these two loops and I have created this particular function. Now you are seeing my output value, the similarity of the documents. That is document 1 and document 100% similarity. Document 1 and 2 it is 0.944. Document 1 and 3 is exact matching, right? It's having some similarity. Likewise, you can take some 100 pitch or lakh pitch and you can do some similarity and you can come up with some kind of result. It's a simple analytics I have explained you here. So the next 10 minutes I am going to explain you the research problem, how to perform classification. Really, that one I will explain you with respect to machine learning perspective. So it's having a lot of scope. That is the thing I am going to focus right now. Can I proceed? Can I proceed? Document classification. Dear participants, is it okay? Can I proceed? Yes, sir. Thank you, Manikam. Thank you. Now I am going to explain you how to perform document classification by using the machine learning algorithm, that is Navy-based algorithm. So all the memories that is in my stack should be released. For that, I have to remove all my memory spaces. I am removing it. Yes, with the script document similarity. Here, okay, fine. Now I am coming with the script document classification here. Okay. So here I am going to use the machine learning algorithm called Navy-based algorithm, and how Navy-based algorithm is used for performing document classification. And I will evaluate all these things with respect to the statistical measures like precision, recall, kappa statistics, specificity, sensitivity. I will show you the confusion matrix, At the same time, I will ask you, I will draw ROC curve for everything. A pakka research problem I'm going to explain right now. Yes. See here, for that, the data is something more important. You know what type that I'm going to take it is, I'm going to classify whether the message is ham or spam. That is email classification I'm going to do. It's a binary classification. I'm going to take a mail content and I'm going to classify it by the label whether it is a ham or it's a spam. That is the thing I'm going to perform right now. Okay, I will show you first the data set so that you will get a clear idea. See here, I'm showing you the data set of my problem. Sir, is it audible? So what are you seeing? Are you able to see the data set? Is it audible? I did not listen. Okay. Yes, sir. Is it audible? Yes. Yes, Manikam sir. Yes, thank you. Data set. Yes. Now I am showing the data set. See, for seeing in the screen the data set, right? It's having some 5,000 observations are there, right? And the two columns are there. One is actual label. I think you know it's a supervised learning algorithm, and this is actual content. My documents. Some 5,000 documents are there, and each document is clothed with some classifier labels. That is either it may be a ham or spam like that. Now I'm going to do some classification task by using the machine learning algorithm Navy base. I'm getting some disturbance. I think someone has not muted their mic. Right. Now is it clear? Thank you. Thank you. See, the necessary packages I'm downloading. Yes. Library TM, G models is a package I needed. Word cloud is a package I have to need, and Snowball C. Yes. Next, I have to get my data set, right? Yes, I am opening my data set. Here is my data set, SMS spams. It's a benchmark data set I have downloaded from UC repository. Okay. For example purpose only, I have downloaded this one. You can take any documents and you can run your experimentation. Yes, the same thing whatever thing I have did it in the document similarity analysis, I am going to do it for document classification using Navy base algorithm. And just seeing the structure, yes, it's having 5,574 observation of two variables, and it's having two attributes, type and text. Okay, you are all seeing in the console window. Yes, the factor is a very important thing because it's a classification problem, you know. So ham will be taken as a one factor and the spam will be taken as another factor, right? Okay, and you are saying if I want to see what is the percentage or level of hams and spam, for that I am using the function table. It's a very important thing. See here, you are seeing in this data set how many data are having clothed with a label ham. 4,827. The spam is clothed with 747. So this much of labels are attached to the data sets. Yes. So mostly the number of spams will be higher compared to that of spam. Yes. So my data set is okay. It's a benchmark data set. Okay. Now by using the corpus for creating the corpus for my problem. Yes. I created the corpus and I am printing it. You are seeing the metadata description. Inspecting it, the content as character. Again, I will apply for first three records. Yes, everything is clear. Now I am performing the text pre-processing activity, that is lowercase conversion. I am removing the numbers and I am removing the stopwords, removing the punctuation still because number of records are huge. You know, see here you are seeing the red color symbol, right? My engine takes too much of time. Right? Yes, it's finished. Right. Next I'm stemming. Next I'm removing the white spaces. Right, fine, finished. Next I'm going to convert into vector space model, that is document term matrix. Right, I converted. Okay. Perform text processing step by step, line by line. Instead of that, you can write it in a single line. It is also possible, right? But I commented that particular part. I will give the code to you, you run it, right? So that you will experience some other thing, right? The performance will be more. instead of writing several lines, if you are going to write in a single line, some efficiency will be there. You can observe it. Right. So next is a data preparation is something more important for any machine learning algorithms, because I am going to prepare training data set and test data set. Right. With this 5,574 observation, I am going to split into training and test data sets. That is the thing I am doing it here. Right. I am taking a first record to 4,169 as my training, and 4170 to 5559 as my test. Similarly, for labels, I have to split. Right. I'm doing it, and I'm using the Prof table function to check. So the table is similar value and conclusion you can come up. Right. See here, both are having same value. So I'm saying my test data and training data, it's good, right? There will not be any kind of overfitting. Everything I'm running it. Similarly, for a important, right? So all features are not necessary for me. So I am going to take some participant ask the question. If the more number of words occurs, what I have to do. So here the minimum frequency I am going to take is only 50. Sorry, not 50. Here it's a 5. So 5 words only I am going to take it. In this way I am going to work it. Yes. Sorry. I'm running. Yes. Yeah. That is the structure you are seeing. These are all the words, frequent words. Now I am performing. I'm splitting it with respect to train and with respect to test. Since it's a binary, or that I'm not case fine. Fine. Next, now I am going to perform actual classification. That is Navy-based classifier I am going to include. For that, I am including the library E1071. That is a library which is used to perform classification. Right. Now I am building the model classifier. I am building by using the function called Navy-base. Okay. Yes. So model is built. Now I have to evaluate it. For that, I am going for prediction. For that, I have to use the function predict. It will take some time. Here testing, I'm evaluating the model. Is it audible? Anyone? Participants? Is it okay?
Yes, sir.
Yes, okay, thank you, thank you, thank you. I think you are mostly seeing the code thing. Right, okay. See, now I built a model, I tested the model with a test set. Now I'm going to give the output. I have to evaluate that model, whether the model that I built is right or wrong. For that, I'm going for confusion matrix. That is an evaluation part. For that, I'm using the library function called gmodels. Yes, I'm installing the package. Yes, it is installed. Now you are seeing the cross tag. That is, I asked the software to perform to construct confusion matrix. for the, yes, the confusion matrix is created. Now you are seeing the values. See here, that is true positive, that is ham, and you are seeing true negative, that is spam, and you are seeing false positive, that is spam ham, and you are saying false negative, spam. So you are having all these values. It's easily computed through programming. No need to write a exhaustive code for all these things. Here I have used Laplacian. So wait a minute, I am getting one. Just a second. Sorry for the break. Okay. Now the confusion matrix is created for my model, for my created model. See here, still I can optimize that model, right? By changing the Laplacian value. So in default, see here in line number, see line number 53. I have given a default value. The default Laplacian value is 0, right? So you can also optimize it by giving the Laplacian equal to 1, right? So I will experiment it with the Laplacian equal to 1. Let us see the performance of that confusion matrix. Right. And running it, improving. Yes, it will take some time. It's finished. Getting it with the Laplacian equal to 1. Still it's red. We have to wait. See, it's not an easiest thing. It's a painful thing for writing the code. Still, yes, we got the result. I'm just printing the first few records. That is the head function. In Python also you will use the same function. And values, only the labels you are seeing, right? I'm doing cross. You see the performance. It's little confusion and then now you are seeing improved confusion matrix. I give all this detail here. Please run this code in your studio and see the result. Then only you will get some clear idea, right? Because you are somewhere else there, and you are not up with the R studio, so it has some kind of disturbance. I know that, right? Just if I show some kind of an awareness, if I motivate you, that is a good thing for me, right? Now, after taking the values, that is true positive, true negative from the confusion matrix, I am doing some calculations. This is my true negative, that is 1200 false positive, and similarly my false negative is 28. From the confusion matrix only I have derived all these values here. See here, 1202, that is my true negative. and 28. 28 is my false negative, and similarly my false positive 7. False positive 7, and similarly 153 my false negative. False negative. By using the I have taken all these values. Now I am calculating remaining things. 2 positive, 2 negative, for calculating what? For accuracy. So the accuracy, I think, the evaluation of any machine learning itself, it will take 90 minutes of duration for me for explaining all these confusion matrix value, how to calculate the accuracy, like that. Okay. So let us see the accuracy of my model. So the accuracy is 97, 48. It's closely related to 1, right? Similarly, 1 minus accuracy is my error, and probability of agreement for calculating the kappa statistics. Kappa statistics is a very, very important terminology for evaluating a model. For that, I have to know the probability of agreement and probability of error, right? I know these values. So I calculated the kappa statistics. My kappa statistics also is more than 0.8. If it is accepted and appreciated, and regarding positive by false negative. Evaluation precision. My precision is 0.99. 0.95 is my precision, and my recall value is similarly my F measure value. F measure is 0.89. It is also good. Yes. I done all the evaluations with respect to my built model with respect to ham-spam classification, right? So now I am going to draw the ROC curve for you. Some calculated result I am going to take for ROC. It's a very, very important thing. Yes. Here I am taking the library ROCR. It's a latest library. Yes, I'm plotting it. See, here you are seeing the result, the right hand side, my classification accuracy, right? And if you want to find really the AB line for finding the area, yes, I can construct an AB line, right? And finally, I'm going to find the area under the curve. This is my area under the curve. It's having the data. That's all, dear participants, regarding on running the document classification activity using R. I think it's a, I never say it's a boring thing. If you know really R programming, right, then you this particular activity, right? So instead of just giving the theory and example, I want to discuss some of the programming things also. That's why I covered this particular topic. So I think you are listening to my lecture for 90 minutes. I think it's exactly 4:30, right? So that's all the content with me related to text analytics using R. I covered two things. One is document similarity analysis by using cosine similarity, and next is how to perform document classification using Navy-based algorithm by taking the benchmark dataset. The benchmark dataset here I have taken is ham-spam classification from the UCA repository. That is the thing I have performed it. So that's all. Still some I'm ready to give all these kind of stuff with respect to Zapata machine, logistic regression, perceptron, artificial neural network, random forest, nearest neighborhood, all the models we have built, right? Right now we are working on a fuzzy with what I have to say. Currently we are working on fuzzy website with RNN, right? In this direction we are moving, and we are working with biomedical documents. We are working with social media data sets, right? In this way we are working right now. That is my scholars are working. And some other application areas are there. Information filtering, analytics. Another area is information extraction. That is, when a passage or a document is given to you, you have to extract the key phases, right? It's called information extraction, which has its own research avenues, right? Similarly, another important area is name entity recognition. right? The name entities are people, organization, location, right? Facilities, vehicles, geopolitical entities, right? Some tags will be there. So you have to tag in a document, you have to tag it with respect to the corresponding items. So that is name entity. But I think most of the research are saturated in name entity recognition. So if you really want to continue your activity or research in text analytics, you can focus on categorization, that is classification, or clustering. There are enormous scope is there, and more number of recent articles are there, right? So please look into that, and you can continue your research. And if you really need any help, you can please contact me at any time. I will really help you, right? Since it's a vast subject, right? That is the thing. Thank you. If you have any queries, questions, doubts, you can ask there. Really a scholar or student, I think it will be very useful for you. And if you really a faculty member, and if you are working in a image or like that, so I think you will never show some kind of interest towards a text, right? But a text is always an interesting field of research, right? Please focus some kind of paper or some kind of work related to text, right? You submit some projects, right? We have submitted more than 6 projects to this particular area, text classifications, right? And 2 of them are we passed in 2 reviews. We are waiting for the final thing. So a lot of things are there happening there in Department of Computer Science, Pondicherry University, Karaikal campus. And one scholar, Vichitrananda from Odisha, he's working on document classification very effectively. And we have one paper in soft computing. It is very soon. It is going to be published with an impact factor of 4.5, right? So we proposed one model. So after publishing, I will share all the content to you here, which is the latest algorithm we have built by using R programming. Only simple R logic is something is needed, right? If you really want to do some wonders related to document classification with respect to machine learning and deep learning, I'm ready to help you do. So that is the thing I want to share at this moment. And most of you said thank you. I am very thankful to the organizer, and I am very thankful to each participant who are very patient enough to listen my lecture. Hi sir, please share your mail ID, sir. Okay, dear, I will share all my code, R code to HDC. So you please take it from him. I will today evening itself. I will mail whatever may be the content that I am having. Right? I will share it to you. You please run the code. Then you will see the difficulty. Right? So you will come up with some error. Some packages will not be installed. Right? Some error will be there. Some versions of packages will not support. Here comes problem. While rectifying all these errors, you will be master in R, right? So whatever may be the content which is there in R, you just try it in Python, right? So through Python, you can integrate R. In R, you can integrate Python. So see, for example, for some certain things, it is very easy for me to do in R, right? But there are something which is missing in R. For that, I can integrate Python in R. That is the same thing. Reverse is also possible. In this way, if you are going to work, you can do wonders in research, right? So as a researcher, I'm saying if you want to choose your career in data science, please master in R and Python programming, right? And at the same time, don't leave the core computing part, that is machine learning or deep learning, right? And the more important thing, please concentrate on the application. So you need to know the domain knowledge. Without knowing the domain knowledge, right, it is very, 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 very difficult to interpret the result, right, to the person which is actually need the result, right? It is my humble request. That's all. Thank you. Thank you very much. Dear organizer, is it okay, sir?
Yes, sir. Thank you, sir. Thank you very much.
Thank you, sir. Okay. Can I leave?
Just a minute, sir.
Yes, sir.
Beulah, please give the concluding remarks.
Thank you, sir. It was really an educative session. On behalf of the Department of Computer Science, I like to extend my thanks to Dr. Kumaravel, who took his valuable time out of his busy schedule. Also, I thank you, sir, for enriching us with hands-on art and its technique and its applications. It was really an insightful session, sir. Thank you, sir, once
Thank you.
again.
Thank you. Thank you, madam. Thank you. Thank you very much. Thank you. I'm leaving.
Yes. So I request the participants to be available tomorrow by 10 o'clock. We'll have two sessions back to back on deep learning. So till then, have a good day.